Alright, welcome back. This is our third video of the year. Yay! This is going to be a continuation of section 1-2 where we're solving linear equations, except we're going to focus more on word problems, creating and solving them. So let's take a look at our first one we have. It says Joshua's going kayaking with a group during one of his vacation days. In his vacation planning, he budgeted $50 for a kayak rental. How can Joshua determine the number of hours he can rent a kayak for himself? We're going to describe two options. So, the important information that I would highlight would be $50 for a kayak rental. So now let's talk about A. It wants to have two ways that we could do that. Well, the many ways that we discussed in class would be, we talked about signing, we talked about using the sign that it gives us here and mental math. So sign and mental math. So we could just do the math based on that, knowing how much. Or another thing we could do is we could create an equation. Do you guys remember the equation we did in class was rental rate times our number, I use the pound sign to represent number of hours, equals 50. Okay, and we could plug numbers into that to solve it. And we also talked about maybe making a table or a graph. All of these options are viable ways that we could technically solve things. Solve and figure out how many number of hours he can rent a kayak for himself with his budget. Let's look at part B. Part B says Joshua found out that there is a $25 non-refundable equipment fee. That's pretty important. In addition to the hourly rates. How does this requirement change the mathematics? So we want to know the requirement changing mathematics. Well, let's think about it. It would change our equation. So because now we would have to have the rental rate times the number of hours plus 25 equals 50. Because no matter how many hours or what the rate is that we use, we're going to have to add in $25. We're always going to have that. So our equation changes. All right. And let's look at part C. How do the processes you use for both parts A and B differ? How are they the same? So we want to know differ and same. So let's talk about it. Both of them require an equation, but the ways to solve them are different. For part A, we would only have to use division because look at part A. We have rental rate, number of hours. We want to know the number of hours, so we just divide by the rental rate. So for part A, we'd only have to do division. To solve it. However, for part B, since we have that 25 added on there, we're going to have to use both subtraction, because we're going to have to first subtract off the 25 from whatever we end up with, and then divide. To solve. So notice there are lots of different ways that we can work with our problems to solve, depending on the way we want to solve it. All right, so that's all that we wanted to do with that one. I just wanted to get your thinking and get you really involved with it, okay? So what we're going to do now is try a different problem. The rest of the book tells you other applications of linear problems in the real world. The first one it talks about is solving consecutive integer problems. But before we can solve consecutive integer problems, we need to know what a consecutive integer is. So what are consecutive numbers? Well, they're numbers one after another. So an example would be 1, 2, 3, or it would be 15, 16, 17, or 30, 31, 32. They're just one after another. So, if I wanted to make an equation to be able to find the first, second, and third consecutive number continuously, how would that work? Well, every single number is always going to be whatever we start with, right? So our first consecutive number will always be whichever the first number is, just x, because we don't know what it is. It could be 1, it could be 15, it could be 30, it could be anything that they start. Well, what do all these have in common? Take a look at them. Well, to go up, we've got to add 1. So whatever x is, we add 1. Look at 15. Whatever x is, we add 1 to get to 16. Look at this first one. If it's 1, we add 1 to get to 2. So I'm going to write second consecutive number is always going to be x plus 1. Whatever it is, we can find the second one by doing x plus 1. All right, what if I want to find my third consecutive number? Well, notice 30 plus 2, 15 plus 2, 1 plus 2, x plus 2. So you see our pattern that we have going here. If I wanted to find my fourth one, it would be x plus 3. My fifth one, x plus 4. So you see our pattern. This pattern works for all consecutive numbers. But what instead I asked you for odd consecutive numbers? Well, odd consecutive numbers are odd numbers in numerical order. So your examples for that would be 1, 3, 5. Or maybe 17, 21, 23. Or even 51, 53, 55. It's whatever order we have it. Well, what if I wanted to make a generalization for any set of consecutive odd numbers? Well, we'd have to find our first odd number. So to find our first consecutive odd number, I didn't write consecutive this time, but it should say first consecutive odd number, not first odd number. We need to ensure that whatever number we pick is going to be odd. Well, anything we multiply by 3, is that always going to be odd? No. Matter of fact, if we multiply something by 3, let's say 3 times 4, that's 12. So that's not going to work. But we know that anything we multiply by 2 is even, right? So anything we multiply, like any even number we have that we add 1 to will always go odd, right? So let's use that knowledge. 2 times any number you can choose plus 1 will give you an odd number. Any number you choose. Okay? Then our second odd number, well, let's take a look. Let's make sure this one works first. 2 times 1 is 2 plus 1 is 3. Yep. 2 times 0 plus 1 is 1. That's how we get our first one there. Okay, so our second consecutive odd number. Well, let's take a look at what happens. You've got to jump up. So if I have 1, then I need to go up by 2. If I have 3, then I need to go up by 2. So it looks like each time we're going up by 2. So This is number 1. The number we start with, 2x plus 1, we're going to have to add 2. So what we get is 2x plus 1 plus 2, which is 2x plus 3. So to get your second odd consecutive number, you need to do 2x plus 3. Let's go for our third. For our third odd consecutive number, we're going to do, well, take the one from before, 2x plus 3 plus 2. Then you get 2x plus 5. So notice you're just going to have to take the one before and add 2, the one before and add 2. So that is your pattern that you'll have to follow for your odd consecutive numbers. All right, we talked about odd. We know we talked about normal consecutive. We couldn't go without even. So these are even numbers in numerical order. Okay, so our examples of those are going to be 2, 4, 6, or maybe 16, 18, 20, or even 40, 42, 44. So, we talked about it a little bit when we talked about the odds above, but how can we ensure that whatever number we have is even? Well, we can multiply it by 2, because no matter what number it is you multiply by 2, it will make it even. So no matter what our starting number. So let's check that. 2 times 2 is 4. So we could do 4, 6, 8. Yep, that works. 2 times 1 is 2. That gives us our 2. Yep. 16. Is there a number? 2 times 8 is 16. Yep, that's going to work. So our first number is always going to be 2x. Okay, notice what's happening next. Second even number. So our second even number is going to be 2x. Well, notice what happens. We seem to be going up by 2's. So 2x, and we're going to add 2. Okay, what about our third even number? Our third even number is 2x plus 4. You're going to go up even numbers every single time. Adding 2, the next number add 2, the next number add 2, the next number add 2. All right, with that in mind, let's solve our first word problem. So it says the sum of 3 consecutive integers is 132. What are the 3 integers? Well, we know that we're talking about consecutive, 3 consecutive integers. So that means that our first consecutive number is going to be 1. So x. We don't know what it is, but we know it's going to be some number that we start with. Our second consecutive number is going to be x plus 1. And our third consecutive number is going to be x plus 2. So, what do we know? Well, we know we have number 1, the first number, plus the second number, plus the third number, is all going to equal 132. So now all that's left to do is combine like terms. So x and x is 2, 1 more x is 3x, and 1 plus 2 is 3. So 3x plus 3 is equal to 132. Now it's just a simple problem that we have to solve. So we're going to subtract 3 on both sides. We get 3x is equal to 129. And then we're going to divide by 3 on each side and get x is equal to 43. That is our first consecutive number. So, since we know what the consecutive numbers are, we could just go 43, 44, 45. There are our numbers. Woo! Or, if we forget that, we can always plug it in. So 43 plus 1 would give you your 44. And for your third, you would do 43 plus 2, which would give you your 45. Because this was x plus 1, and this was x plus 2. Alrighty. So that is how you'll go about solving your consecutive ones. You're going to solve odd and even ones very, very similarly. I'm not going to go over those in this video, but if you ever need access to these notes, they will be on both your OneNote and in class for you to take pictures of. So now, let's talk about a different type of problem. Let's talk about a mixture problem. So it says a lab technician needs 25 liters of solution. That is 15% acid for a certain experiment. But she only has a solution that is 10% acid and a solution that is 30% acid. How many liters of 10% and 30% solutions should she mix to get what she needs? So the important part, she has 25 liters of 15%. But she only has solutions that are 10% acid and 30% acid. And we want to know how many of each of these solutions she should mix to get what she needs. So first step of everything is we need to write an equation. When writing an equation, we always need to define our variables. So we're going to let x equal the total liters in one solution. Then we have 25 liters. We need 25 liters of 15% solution. Would be equal to, well, the total liters in one solution would be x liters of 10% solution plus, now let's talk about it. If 25 is the most we need, and we know we're going to have x of whatever 10%, whatever is left of the 10% is what we'll need in order to make 25. So what we're going to have to do is 25 minus x. So whatever we've used up for 10, then 25 minus x will be what we have left, which we're going to use of the 30% solution. So if one solution is x, we know the second one has to be 25 minus x. Okay? So now all we have to do is some solving. So if we want 25 liters of 15%, that's going to be 25 times 0.15, because we never work with percents, we always turn them to fractions. Then that means we're going to have x, because that's our number, of 0.10 plus 25 minus x of 0.30. Now we just simplify. Well, this is going to become 3.75. This will become 0.1x. Plus, we're going to distribute. So we're going to end up with 7.5 minus 0.3x. Well, if we combine our like terms, like term 1, like term 2, we're going to get 3.75, because we haven't changed it, is equal to negative 0.20 x plus 7.5. Well, now all we have to do is get it along. So we are going to subtract 7.5 on both sides. And when we do that, we'll get negative 3.75 is equal to negative 0.20x, because these cancel. So then all we have to do is divide by negative 0.20 on each side. Then we get x is equal to 18.75. So, since our x is our 10% solution, and our 25 minus x is the 30% solution, then we do 25 minus 18.75 equals 6.25. And just x in general, well, that's 18.75. Super easy, right? So our rule is 18.75 liters of 10% solution and 6.25 liters of 30% solution. And yay, we just solved a mixture problem. Alrighty. So let's keep going and looking at the type of problems we can solve. I'm not going to do this extra one up here, but you can solve it out on your own, or you can check in and make sure you got it right by looking in on the OneNote or by looking at this in class in our binder. Alright, so look at example 5. It says, 4 friends use an online coupon to get discounts on concert tickets. They spent $312 for 4 tickets. What was the price of one ticket without the discount? So we want to know the price of one of them tickets without the discount. Well, first things first, we're gonna have to define our variable. So let P equal our original price, because we don't know it, and that's what we want to know. Well, how many tickets did we buy? Well, look at it. It says 4. We bought 4. So 4 times, and what was the discount? The discount for each ticket was 15. So P minus 15, because our original price is minus 15 is what we paid for. So this is the price of the ticket, and we bought 4 of them. Okay? So 4 times P minus 15 equals 312, because this is our total price. So just in case you forgot here, this right here, cost of one ticket. This total. 4 tickets. Okay? Now all that's left to do is solve. So for sake of this, I'm going to move it up and save a little time there. So 4 P minus 15 equals 312. So what we're going to do is we're going to divide by 4 on each side. We're going to get P minus 15 is equal to 78. And then we are going to add 15 to each side, because remember, original price means we don't include the discount. So we get P is 93. But can I just leave it, if we're working with a word problem, as P is 93? Absolutely not. So we have to say ticket price without discount was $93 each. Yay! We just solved a word problem with a linear problem. Alrighty, let's try another one. Again, I'm not going to do this one for you, but we are going to do our last little example. So, take a look at number 6. This is a work/time problem. It's very, very fun. They have a little bit of goodness going to it, so let's work with it. LaTanya will walk her bike from her house to the bike shop, which is 1.5 miles from her house. So her house to the bike shop is 1.5 miles. To get her bike fixed, she expects to wait 30 minutes for the repair. So she's going to wait 30 minutes for the repair. Then she'll ride her bike home. Can she be home in 1 hour? Alright, so we got a lot going on here. Well, first things first, we got to write the equation. Well, first things first, she's going to have the time she spends walking, because we want to know, can she be home in an hour? Well, the time she spends walking, we're going to have to take that into consideration, plus the time she spends at the shop, plus the time she spends biking home. Equals our total time. All right, let's plug in what we know. So what do we know? Well, we know that according to this here, she is going to spend 1.5 miles walking from her house to the bike shop. So that's 1.5 miles. And she can walk at about 3 miles per hour. Okay, then we're going to add that to the time at the shop. Well, she expects to spend about 30 minutes at the shop. 30 minutes is 1/2 of an hour, so half an hour at the shop, plus the time biking home. Well, notice it tells us that she's going to bike 10 miles per hour. So the distance home is still the same, 1.5 miles, but this time she's going to be going 10 miles per hour. And all of that's going to equal her total time, which is what we're actually looking for. Is her time going to be less than an hour? Alrighty, so let's work it out. Well, first things first, we want to get rid of the fractions. Oof. So let's pick our least common multiple or greatest common denominator of 3 and 10. I'm thinking something that goes into both 3 and 10 is 30. So what we're going to do is 30 times 1.5 over 3 plus 30 times 1/2 plus 30 times 1.5 over 10 equals 30t. We are doing it to every part of the equation. Okay, now when we put these in our calculator, we're going to get 15 plus 15 plus 4.5 equals 30t. Well, we add 15, 15, and 4.5 to get 34.5 equals 30t. So to get t by itself, we divide by 30 on both sides, because that's what we want. We want to know what t is. Well, 34.5 divided by 30 is 1.15, and this is in hours. So she gets 1.15 hours. Can she get home in an hour? No, she cannot. So no, she cannot make it home in 1 hour. All right. So that is all for this lesson. I didn't do all of the problems that are in your note sheet, I know, but you have access to those on OneNote as well as in class if you want to take pictures of this document. I hope you had fun, and as promised, I kept it lower than 30 minutes. Yay! 30 minutes or less. Bye! Have a great day, and please come get help if you need it.